Hi guys, Rita here. Today we're going to look at this short question that focuses on probability, so let's get straight into the question. So in part A of the question, they tell you that the table below shows prizes that a player can win in a game, as well as the probability of winning each prize, and they tell you that it costs €10 to play the game once, and they also tell you that the game is fair, so that is the expected value of the winnings, taking the cost into account, is €0, and they want you to work out the value of x. So the first thing we're going to do is we're going to write out the formula to find the expected value. So that's going to be E of x is equal to the summation of x by px. And basically what that means is we need to multiply out every possible outcome by the probability and then add our values together. So if we do that, looking at the first prize, it's none. So that's going to be 0. And the probability of winning that is 0.3. The second prize is 2. Probability of winning that is 0.4. Then the third prize is x minus 10. And then we're going to multiply that by 0.28. And then we have x by 0.02. And now we can't forget to take away our cost of entering the game. So that's going to be minus 10. So now we just need to go ahead and multiply this all out. So this is what it should look like when you multiply it all out. And we know that this is equal to 0 because the game is fair. So we can go ahead and start to tidy this up. So 0.28x plus 0.02x will leave us with 0.3x. And then we have 0.8 minus 2.8 minus 10. So that'll leave us with minus 12 is equal to 0. So letters to one side, numbers to the other. That'll be 0.3x is equal to 12. So x will be equal to 12 all over 0.3, which will be equal to 40. So that's your answer to the first part of the question. And to get that answer, you get a total of 10 marks. In part B of the question, they tell you that A and B are mutually exclusive events, with the probability of A being 0.1 and then the probability of B being 0.4, and they want you to work out the probability of A intersection B and then the probability of A union B. So the first thing is we need to know what mutually exclusive events are. So that basically means that the two events can't occur at the same time. So if we look at the probability of A intersection B, if these events can't occur at the same time, then that's just going to be 0. So that's your first answer. And then when we look at the probability of A union B, this will be the probability of A plus the probability of B, and we know that our intersection is just going to be 0. So this will be 0.1 plus 0.4, which is equal to 0.5. So that's your second answer. So to get both of them answers, you get a total of 5 marks. In part C of the question, they tell you that C and D are two other events with the universal set U, with the probability of C being 0.5 and the probability of D being 0.7, and they want you to find the maximum value that the probability of the complement of C union D could be. So here I've just drawn out our wee Venn diagram. So they're looking for the maximum value that the complement of C union D could be. So that means that we're looking for the maximum value this area out here could be. So in order to make that the maximum value, we need to try and find what the minimum value within the two circles would be. So we know that the probability of C is 0.5. So I can put 0.5 in here, and that will still leave the probability of C as 0.5. So with that in there, we know that the probability of D is 0.7. So that means that here should be 0.2. So we still have the probability of C to be 0.5 and the probability of D to be 0.7. And that's the minimum number we can have in there. So now in order to find the probability of the complement, that's going to be 1 minus 0.7, which leaves us with an answer of 0.3. So that's your answer to this part of the question. To get that answer, you get a total of 10 marks. In part D, they tell you that E is the event that it will be raining tomorrow morning, and F is the event that I'll wear a coat going outside tomorrow morning, and they want you to explain why it would not be reasonable to assume that E and F are independent events. So an independent events mean that the occurrence of one event does not affect the probability of the occurrence of another event. So if you think about it, if it rains tomorrow, well, that means that I'll be more likely to wear a coat outside. So that means that these events definitely are not independent. So we need to put that into words. So I've just written that if it rains tomorrow morning, I'll be more likely to wear a coat. Therefore, the probability of E affects the probability of F, meaning these events are not independent. So to say anything along those lines, you get a total of 5 marks. So that concludes the question, guys. Hopefully it's all a bit easier now, and thanks very much for watching.